Hello and welcome to another Hedgehog Make stream. My name is Austin, aka Zombie Hedgehog, and today we are going to be unboxing the Anycubic Kobra 2 Neo. So this is their brand new kind of budget line printer to hopefully compete with the other lower cost printers. So this is coming in at a whopping $199. So it's one of those printers that you kind of just have to check out. So without further ado, let's jump right into the unboxing. So we are recording this live on YouTube, so welcome on in Nick, Canrog, Biggerfish, Engineering, and Robert. So I've already kind of opened the box. There is no branding on the box at all, which is kind of interesting. Inside of the box, it comes packaged like so. We have this foam on top with a little mini cutout for the build plate. So let's see what that has. It's just a build plate. That's pretty interesting. So they've included a double-sided textured PEI. That's very interesting, and I haven't seen this on any printer that I know of. A black double-sided PEI. Even the... I'll be comparing this a lot to the Ender 3 V3 SE, which that came with a, what is it, like a PC bed. So that's pretty cool. So let's see. So that comes off. Put that aside. You'll want to make sure to keep the packaging in case there is a defective unit and you have to return it. So let's see. Inside the box, we get a little quick start guide. We'll take a look at that. The manual. We have the world's smallest sample filament roll. Wow. Okay, 10 meters of not white but gray PLA. Something different. Some accessories. We'll take a look at that. Inside of this, there is the power cable. We have a spool holder. This is a locking one, and it's kind of a smooth, non-roller based one. It's very black. I love the color blue, though. It's a very dark blue. Looks nice. So, the gantry comes zip-tied in place, which is kind of cool. We'll check the V-wheel tension and see if any of them come flat out of the box. I think this is a full V-wheel printer. Oh, it's only single Z too. Yeah. This is going to be an interesting one, guys. Very interesting. It has a... What is this? Spool holder? Oh, the spools go on the side, don't they? So it's like a side mount spool holder. Interesting. Okay, that's it for that. So far, very well packaged, at least. I like the multiple layers of foam. Very well protected. Has a pre-applied magnet with some interesting cutouts for the leveling, or the screws. Okay, interesting. Let's pull this out of the box, if I can. That comes out in one piece. It has some foam that comes with it. I'm just going to put this aside for now. Alright, then we have the tool head, and it comes separate. So, a very cute little tool head. I'll take a closer look at that. With some Boasting tube already attached. Okay. The screen. Wow. That is a tiny screen. Yeah, that's small. Alright. And I think that's it. That's it. So I'm going to put back... let's put this aside for now, but I'm going to put all of the foam back in the box. And then store the box. Alright, let's get the main body of the printer up here. I'll switch cameras. So here we go. Let's start by removing some of the packing materials from this. So this does come very well packaged. No chance of it being damaged. Well, there's a chance, but they've made it so it's very low odds of it getting damaged. What's the plate size? This is, as far as I'm aware, Ender 3 size. So your standard 220 by 220 build volume with a 235 plate. To confirm, let me grab my full flex sheet and slap that on. And yes, that is indeed the same exact size. In fact, a little bigger. Let's compare that against the sheet they include. So they do, okay, so their sheet is slightly smaller. So an Ender 3 sheet comes a little bit oversized. I think 235 by 235. But this sheet is smaller. Meaning that you can buy, I hypothetically buy an Ender 3 bed and it'll overhang. But do note that this one is a little smaller. Maybe I can go with the overhead and show you that comparison. So they're both black, but we got a good 5-ish millimeters on this side, and 5-ish on that side. So it's about 5 millimeters on each side smaller. Interesting. You'd think they'd go with a more standard size, but yeah, it is what it is. So there's no indexing, so you do have to manually line it up correctly and then drop it down. I find it best to kind of just put it at an angle, kind of eyeball the rear and the sides, and do that. You can also kind of put your finger on the corner and use that to level it. And then you can kind of slide it by hand. It doesn't have to be perfect, but it should be pretty close. You'll get the hang of it. But just a quick inspection of the chassis. We do have a rigid mounted bed on 4 standoffs. It does have a V-wheel Y-axis. Has a tensioning knob on the front. A rear-mounted stepper. This kind of feels like your typical Ender 3 clone, per se. That's kind of what I'm getting at for first impressions. Even the power supply layout, that kind of reminds me of Ender 3 style. Except the power supply is huge. Wow, that's a thick power supply compared to a standard Meanwell. We are set to 115 volts. That's good. The control board is in the front here. We have some dead space on the bottom. I haven't really seen this design before, where the side extrusions are L-shaped. Kind of a weird extrusion profile. Alright, I'll take it. We do have a... Alright, we have our first issue. Right over here, we have a nice metal containment area for the wires, but no grommet. So we have a cable running through a metal... It's not sharp, but it's a metal opening. Let's go ahead and take this apart to see what we're working with. Make sure it's grounded properly. Just unpacked from my trip to Earth, so hopefully I can find all of my tools. Check this out. I have a spare hex tray handy. Maybe I do, maybe I don't. It's alright. Dead space equals room for a pie. Yeah, there is plenty of room for a pie down here. Plenty of room. It's very open. Alright, so those are all the same size screw. Let's see if there's any more. There's one more in the bottom here. So 4 screws to take off this cover for the power supply. Okay. Let's take a look. So we have our power inlet right here. And we have our line neutral ground coming in. The ground goes to here, but I don't see it tied to anything else. So I don't see any chassis grounding at all, as far as I can see. It looks like that one grounding jumper, the bonding jumper, just connects to the power supply. So technically it is tied to the chassis of the power supply, and then the chassis power supply is screwed to here, but it's kind of a bummer that it's not attached to even like this cover. Like, it barely passes. Let's just put it that way. Barely passes. What I really don't like is this right here. So it's not as bad as the original Ender 3s, but the cables pass through this. It's smooth. It's a smooth opening, but it is still metal. So if there is a short circuit, then this can become energized and cause issues. So I do not like that at all. At the bare minimum, the power or the DC cables can be sleeved to avoid that. So not a great start. Not an amazing start. So hopefully the firmware is going to have some redeeming qualities, because the overall build is not impressing me right now. How'd this go back on? Let's see. Okay, it kind of slides in place. So let's get that reassembled. A plastic cover would be ideal in this instance, absolutely. That's why a lot of electronics are plastic for insulation. Alright, one more screw to attach this right here. So at least the cover's held on pretty well. Again, I'd like to see a grommet where the cables pass through. And then on this side right here, this is plastic, so that's fine. This piece is just plastic. This is metal. So while we're on the bottom, we might as well take a look at the board they're using. See if we can get to there. So there's 1, 2, 3. Oops. Right into the ground. So I did pre-order this printer. I did buy this, full disclosure, with my own money. I got it for $160 on pre-order. The power supply is a 400 watt power supply, not like the standard 350. It is a ZL-PT400-24, so I'm guessing it's a 400 watt power supply. Okay, how do I get into here? Ooh, is this like plastic? Okay, so it looks like it's clipped in place right here. Let's see if I can try to figure this out without breaking it. No immediate way of getting into this thing. I see some potential areas here. Okay, yep, that's it right there. So 2 little things in the back you press up on. Then the front is also clipped in, yeah? Kind of a jank solution, honestly. Just have it screw in and not clip in. So the bottom cover comes off like this. It does have a pretty beefy fan. This is something you typically don't see for board cooling, but it looks like it's an 80mm fan. It's a 70-15. So 70mm fan, almost 80. That's pretty nice. It'll be a lot quieter when it's running to cool off this board. I'm a little bit concerned with the power supply noise, but we'll get to that. So this stays attached. They use a little bit of glue to hold everything in place. This red glue, it's not even super glue, it's just like goop. So it's not coming off accidentally, but it's also just not coming off in general. So let's just put this aside for now and take a look at the board best I can. So we have 4 stepper drivers with little heat sinks on them. The power cables, we have what looks like two ferrule connectors. Are these the input? No, these are the bed. The bed cables are ferrules, and it looks like the main inlet is non-ferrule connector. Everything else looks pretty generic. It's a custom board. It's a Gorilla Gen V4.0.1. Interesting. There's a little ribbon cable. I'm guessing that's for the screen. So yeah, that's pretty much it. Very basic. I do like the housing, how it's all in a plastic area. You're not going to be slapping in a random board, but it looks like you should be able to take this out, and if you wanted to in the future mod this and put a better board in there, you could hypothetically mod it, but it won't be easy. It's not like some of these other machines. You'll have to put a little bit of work into it. So to get this back, we're going to just kind of click it in place, I guess, because it's just like this. So it kind of pivots on here, I think. It's weird. Okay. Yeah, I don't like that. You pick one, screws or snapping, or like one screw. Oh, that's the wrong size. Looks like there's 2 longer screws for the recessed connectors. And these thread right there. Alright. The main reason for getting this printer is to compare it against the Ender 3 V3 SE, because they both come at a MSRP of $200. So it'll be very interesting to see how each brand kind of, optimizes their BOM. So Anycubic has cheaped out on the motion system and has gone with V-wheels. Now, luckily, V-wheels can be upgraded to linear rails. That is possible. With this version, it'll be a little bit difficult because you'll have to use an MGN. Actually, it'll be extremely difficult because the belt is on the top here. So you can't really put a linear rail on the top, and the sides are raised. This is kind of like my BQ BX, where I had this center rail type of thing. So you can't use the MGN9 on the side because the actual carriage would hit. It's like bigger than the rail, and you can't use an MGN9 because this is V-slot. So it would be quite difficult to convert this to linear rails without doing some extensive modification, like raising up this whole entire bar or something like that. So not an easy printer to just straight up mod. But I've been told that V-wheels do last quite a while if you have them tensioned correctly. Personally, I don't really have any printers with V-wheels, so another reason for getting this is I get to play around with V-wheels and test that out. So that's fun. Let's get assembling then. Now that we've investigated the main chassis, take a look at the safety. I would rate it about a 7 out of 10 for safety so far. Maybe a 6 out of 10, given that I don't have any chassis grounding specifically, nor the pass through for the metal, like the metal pass through. I don't like that. All right, so step 1 is install frame. So we're going to screw together the frame. All right, easy enough. Zoom this back out a bit so you can get that. So before we put on the frame, let's give that a quick once over. So single Z axis to start. This is something that I thought was ancient, especially with V-wheels. The issue is this will always either lag or lead this movement. So because they're not tied, there's a chance that your other axis or this other side will be a little bit imprecise. That's the main idea. You can potentially add another Z motor. We'll see how they're incorporated, but as of now, it doesn't. It looks like you'll be very typical to a standard like Ender 3 style layout. In fact, you can probably get like an Ender 3 kit. But maybe there's gonna be a dual Z kit for this printer. Just note that out of the box, you might have some issues with dual or the lack of dual Z. I'll also note that the Ender 3 V3 SE comes with dual Z out of the box. I like the color. Again, the blue is nice. So let's get this mounted on the printer first, and then we will detach the zip tie. So we will have to tip this upside down. This feels very much like a typical Ender style printer, where there's no easy way to do this. Yeah, not a great way of doing this. You'll have to like tilt it on its side and get one of the screws started by hand. Let's see if I can find the fasteners for that. Welcome on in, everyone who has just tuned in, watching this live. If you're watching this in the future, make sure to like and hit the subscribe button. I do a bunch of 3D printing unboxings, custom printers, and I'll be doing reviews of specific components, etc. If I can even find the screws for this. That's filament. We have a USB, SD card adapter, a SD card in a little baggie, a volcano looking nozzle. Interesting, I haven't seen that style before. Fasteners, there we go, and some wrenches. And some miscellaneous tools. I don't know what this is. Anycubic, huh. We will have to find out what that is for. So we're starting off with the Z installation. So what does this want for screws? It looks like there are two different sizes of screws. Oh, and I can see the cutouts now. So on the bottom of the machine, because they're using a custom kind of L-shaped profile, one of the screws goes into here, then one of them goes down here. So the longer screw will go through that top port. So I'm going to try to balance this on its side and orient this correctly. So the stepper motor goes on the power inlet side. So kind of like that at an angle. I don't have enough hands for this. This makes me miss the folding design of something like a Focus, where it's easier to install. So far for assembly, I would give this a like 4 out of 10, considering how assembled printers are nowadays. Maybe 5 out of 10. I don't know why I'm starting to rate these things, but yeah, this is the reason why. I have to like balance it. I'm gonna use one of my own fasteners or my own tools. It's just 4 bolts. Yeah, it's 4 bolts. Just 4 bolts for this. But you gotta get it at just the right angle. So what I'm gonna do is I'm just gonna attach one side. Oh dear. Actually, so they've made it really awkward, where they've zip tied the gantry down at the bottom, so you can't actually get it connected because this middle part is hitting. So we're gonna have to cut these zip ties to carry forward and then manually raise the gantry up. Kind of an oversight on their side. Interesting that they're zip tied together. Make sure not to cut any cables when you cut these, and then we can manually, oh wow, we'll have to manually screw this up. And oh yeah, my hand's already full of grease. Oh, the lead screws are super greased. Very greasy. Not loving this assembly. Now, this is Anycubic's entry-level printer. I'm not expecting it to be completely perfect, but at this price point, especially with offerings from other companies around the same $200 price, there's definitely some quality of life improvements that I think could be had for. But we'll see. There we go. That is screwed in. And let's get this installed. They do have some locking washers, so this will hopefully not loosen up over time. And there's a cutout for the Z extrusion, so it kind of falls into place and hopefully lines up fairly well. So those are in as much as I can by hand. I'll flip this around and then do the other side. Four screws is 3 too many for me. Yes, yes it is. Oh man. Hello Maker Viking, how's it going? Out of Adam. Okay, these are all attached. Great, so our Z-axis is on. And it is almost ready for prime time. Getting there. I don't want to have to touch the... Oh, I'll have to touch the tool head again, won't I? Or the lead screw. So you can't lift this up really by hand because there's a lead screw back there. So you're forced to manually rotate this. I would recommend rotating it by this right here because they added a lot of grease on that lead screw. They don't want that thing wearing out. It's a very fancy looking coupler system. I don't know what's going on here, but it looks like it has some, it allows for some play, kind of like a Wobble X. So if there's any twisting in the lead screw, it'll compensate for that. Interesting design. I don't know if that's in their explanations. No, it's not. But that's interesting. I haven't seen that before. The motor layouts are very typical of something like an original Ender 3, where the motor's on the outside and it just runs a belt through the extrusion. These are not Gates belts. These are standard timing belts. Also, this has an open bit right here, so this is where you'll kind of drop stuff and then lose it on the bottom of the printer. Alright, that was step 1. So step 2 is install print head. I can do that. So the print head, we haven't taken a look at this yet. It looks pretty neat. I'm not gonna lie, I like this design. It's a little bit bulky, but it doesn't look like the X1s and that style. It looks a little bit different. It's something about the style of it. It kind of looks good. This looks a lot better than the Ender 3 V3 SE toolhead. So if you're just buying it for looks, I'd say this one is a winner. We have a little tightening. Let's zoom right into this. We have a tighten port, I'm guessing for the extruder tension. We'll take off this cover and see what's underneath. But visibly, the fan is on the back for the tool head. So this must be the part cooling fan on the front. And the back has the Hotend fan. And it is running a volcano block. That's interesting. So I'm pretty sure this is a pretty basic volcano block, volcano style block with a volcano nozzle. So be able to use standard volcano nozzles. And that should get you higher flow than a typical V6. So that's kind of nice to see. We have an inductive probe, no BL touch here, and there's a toolhead PCB. So let's just tear this apart before we install on the printer. I'll do it down here. Completely take this thing apart. See what we're working with. So take off the cover. You unscrew it from the back. Looks like there are 2 screws holding it on. Well, you should learn how to do this in case you get, something breaks. It does look like this comes off of the tool head very easily though, so we'll see how easy it is to assemble it. It looks like there's these 4 screws right here. So 1, 2, 3, 4 into this metal chassis, and that's what attaches it. So in here, this cover comes off. Oh wow, that's kind of intense. So in the front here, see if I can show this, there we go. On the front, we have a beefy fan. Wow. It's a 0.2 amp, 24 volt fan. It looks like a 50-20 blower. Maybe it's just a 50-15 that has a wide chassis, but it's a custom blower. I have not seen this before. And the ducts, it has dual blowing ducts, and they're not the same. So they've definitely done some flow optimization, hypothetically, to kind of get the most performance out of this design. I don't know if this is a clone or has taken inspiration from someone else, but it looks interesting. There's even a slot right here. So this side's shorter and it has a bit that blows out here. I don't know. It's weird. Very, very interesting. Can't really... Oh, I can remove it. Good. So this removes with a connector here. How easy is it to remove that? I don't know if it locks in place or if you have to remove the fan for some reason. Does it lock in place? It doesn't look like it's a locking connector. No, it looks like a standard fan port. Is it? No, it's a smaller connector, so it's a 2mm, I think. Yeah, 2mm instead of the standard JSTs. So, but it's standard though, so you'll be able to get a JST connector and recrimp that if needed, I believe. So this is our extruder. It's pretty long, but it looks promising. We have a very beefy heatsink here with a volcano style Hotend. I kind of like this. So the block itself attaches with the set screws. I mean, if we're going this far, it's been pretty easy to disassemble, so might as well continue disassembling it. Let's see, so these are 2mm. So if you have to replace, if you have a major clog and you have to take this apart, pretty easy. You just loosen those up. It kind of gets held in place by the connectors. But here we go. Ooh, is this a PTFE lined Hotend? Is it? I doubt that. But it does need PTFE between the extruder and the nozzle. But this is like, oh, it's in there. I can't tell. How far does that go in? That much? Ooh. That does look like it's PTFE lined. Is that what you consider that? It goes in about to the end of the block. Let's see if I can take that out. Do I have a little nozzle wrench handy? I don't really want to take it out, but what do they advertise for specs on this thing? For temps. It'll be pretty obvious. 260C. Yeah, so is this PTFE line then? Yeah, I think that's what that means. So the PTFE goes all the way to the nozzle. It doesn't look like it touches it though. It's kind of a weird setup. Actually, it's a really weird setup. I kind of want to see what's going on in there because it looks like it's blocked. Hard to explain, but that's weird. So you go through this all the effort to make this, and it's PTFE lined? $260C should be all metal. Well, usually generally when a company advertises something as 260C, that means it's not all metal because hypothetically these are rated to 260, but they're not really during normal operation. You want to run them at like 240 maximum. But I don't know if it actually touches. Regardless, this goes right up into here, and it lines. the heat break. So in all intents and purposes, actually it goes even further. Yeah, that goes right into the block. So it's a PTFE lined heat break. That's weird. That is weird. I don't get that. Now, I'm sure you can buy a replacement heat break, but once again, why can't we just include an all-metal Hotend? Given the Ender 3 V3 SE doesn't for the same price, but still, I just have a feeling that these should be gone from existence. That being said, if you want to upgrade it, it's not too hard. You just take this out and then swap it out. At the end of the day, not a huge deal, and it'll still print fine. So to put this back in, you slide that in like that, and that goes in like this. I'm not going to detach it because it's already tightened, and I don't want to mess with that. So you press it up against the top, and you tighten these two set screws, and this holds the whole thing in place. So the design of the Hotend, though, that's kind of nice. I don't mind that. Medflinger isn't really ABS market. That's true. That's very true. But you can print ABS on an open air printer. And yes, you can print ASA at 240. You can, but you want to generally print it hotter. Some materials do prefer to print hotter. So conflicting, but we'll carry on. The extruder, I don't know what kind of extruder this is, but no indication of anything. I'm guessing it's similar to a BMG. BMG style. Gear reduced. Because it has a well, if you consider that a pancake, a smaller NEMA motor instead of a large one. So I'm guessing it's, well, the output shaft is here. So yes, it is probably BMG gears in here. The PCB is kind of cool. So we have our little heater, which does use a standard connector. So the heat or the thermistor cable is non-standard, but the heater is standard. It's just a microfit. That's kind of cool. I like that. It's even, for some reason, it's bonded to the. They're bonding the ground here to the actual chassis. They paid more attention to the design of this tool head versus the actual power inlet of the printer. Kind of weird. So this team did a good job. Like, this thing is pretty well designed in my opinion, just by first impressions. Now, is this a standard Hotend? Like, what is this thing right here? I have no idea what this is. If it's a, if you can buy a replacement for this, etc. I can't say I've ever seen this specific thing, but it looks pretty nice. Besides the fact that it has a PTFE line heat break. Oh well. Volcano block looks like the same way you install volcano cover. This is not coming off at all, so not bad. Kind of clicks in place, very satisfying. No, this is much bigger than a bamboo heatsink. Like, this is massive, which is funny because it's a PTFE line. Alright. Let's get this back assembled and get this installed on the printer. So reversing what we did, we have this cover here, which I'm expecting people will make specific mounts for this, or a custom something. But default, it does look kind of cool. Doesn't look bad. So that wire can go kind of anywhere. And then that slides in like this onto here. And then just 2 screws on the back. So pretty cool. And there's also a ground, like a bonding jumper for this screw right here, which I've never seen in a 3D printer before. But it exists. That's probably to comply with grounding. Because this is metal, they need to ground it, or like the exposed body of the NEMA. Something like that. I don't know. But that's probably just to comply with safety regulations. Alright, so this is good. As is. I think we put everything back together. So let's install it on the printer, finally. Yeah, metal case. So this is plastic right here, but this is metal. And there could be a short on here. So that's kind of neat. I'm wondering if they... Oh, yeah. Oh, wow, that's interesting. Okay, so... Sorry, a sidetrack. They've also added in a bonding jumper here as well. So they are semi-properly bonding or trying to comply with regulations for grounding. Look at this. Have you ever seen that before? It's a little jumper right here. I remember talking to... Who was it? I think it was Lulzbot, and they had their custom prototype printer, but all the motors had to be specifically bonded just like this to comply with regulations. That's interesting. So that'll allow them to enter more markets and just be overall safer. And then they run wires through a non-grommeted metal slot. Alright, well, whatever. So to attach this, I wonder if it gives me instructions. Nope, not at all. Okay. Probably in the manual, but it looks pretty simple. So this right here should snap in. Yes. How does that work? It doesn't really snap in. Kind of snaps. It's weird. So what you want to do is pre-attach 2 screws on here. That's probably in the manual, but we'll figure it out by ourselves. There's 4 screws, 4 smaller screws left. Looks like they're all the same length. So just get 2 of them started on the outside here. Just a little bit. Are they the same length? Yeah. Get those started. And then it'll kind of just slide on like that. Tilt this around. So it slides kind of on. And then the bottom, there's clips. Plastic clips down here that lock into place. So the actual plastic is locked into place. And then you screw in these right here. And that holds it in nice and firm. Already, it feels pretty, pretty rigid. And then there's 2 additional screws after the fact to screw in. This is probably one of the most secured tool heads that I have used. And it's on B wheels. Oh, boy. Yeah, all that, and it's on B wheels. So I can see this translating very well to a linear rail system. But like I said, it's not going to be easy to modify, or at least straightforward. Let's quickly check the tensions. Looks like this tension is fine. Might be a little on the tight side. We'll leave it as is. Same thing with that. They're all kind of on the tight side. But that's a neat tool head design. Trying to touch the lead screws because they're super looby. Yeah, that's pretty rigid. As rigid as it could be. What I like to do is touch the nozzle and try to move the nozzle back and forth. And if you can't move the nozzle at all, then it's fine. Not just V wheels, a single Z. Yeah, single Z and V wheels. It really feels like they've taken a stock Ender 3 and added what is hypothetically some pretty neat features. All right, why is it a 400 watt? 400 watt. That's what I don't get. Like, is this like a superheated bed or something? Like, what wattage is this bed for a 400 watt power supply? Does it say on the back there? Does Anycubic warning? I don't see. Like, is this little bed more powerful than, let's say, an Ender 3 bed? It does have a volcano Hotend. I don't know how many watts the heater is. Maybe it's like 60, maybe 70. But 600 watts? That's weird. It's weird. Or, sorry, 400 watts. For this, like, custom thick power supply. Doesn't make too much sense. Also, it doesn't look that great. The power supply is exposed in the back. So you just see, like, the metal from the power supply. What I really don't like is there's fins here, and looks like you can kind of drop stuff in here. I don't like that at all. This is a weird design. Alright. Carrying on with the printer, we're almost done. Almost done here. Next step is to install screen. So it's the world's smallest screen. Let's do a peel on it while it's here. There you go. Tiny. Looks like it's a matte finish screen. And this installs... Oh, sideways? Okay. Like that? Alright. So we're going to use the last two screws here. Do many printers come with a reverse Bowden? That's a great question. Most printer designs will have a top-mounted spool holder, but as we know, that's just not a good design because it adds extra torque on the top of the printer. And when you're printing fast, that is not what you want. For a slower printer, it's fine, but when you start printing faster, you don't want to have a spool mounted to the top of your printer. It just is what it is, unless it's a super rigid frame. Even then. So this printer is special, and I'll install it in a minute. But first, let's get the screen attached. Just screws on like this. I'm used to these big Ender-style touchscreens, but that's fine. Maybe not touchscreens, but regular screens. So that has a little cable. It plugs in the back there. Looking pretty good. Not gonna lie, it's a pretty nice looking printer for what's essentially a basic Ender 3 clone. Next step is for attach the filament holder. So this is special. This is actually a bit special. So does this just clip on? Don't tell me it just clips on. Does it just clip on? Oh, it does. Wow, it literally clips on. Oh, that's on there. Clips on, it can slide back and forth. Okay. So this will go kind of like that. Actually slides a little bit easy. The bottom matches the profile of the feet. This is plastic, it's not grippy. But it supports this. And then they have that lock-in spool holder right here. So the spool holder is on the side instead of the top. I'm not going to bother with this. I just, no. So let's grab a spool of filament to try out. What do I want to use today? Gotta use something that's not abrasive. Let's actually use this one that it's got. It is Cookie CAD. It's a really nice pale blue elixir. Has a lot of sparkles in it, so that'll be a pretty good filament to test out. So the way that this works is the filament loads on the bottom here. And it comes with this reverse Bowden. And it has the adapter right here. So you just push that in. Oh, it's a pass through. So it goes all the way through. Push this all the way to the side. And kind of gauge. You want a little bit of slack in it. Like that. So there's no tight bend. The most you'll ever print is around here anyway. So you can kind of press this through. There's no stopping though, so that's something that's kind of weird. But this means you'll be able to feed it from the bottom. I think this is how it goes. Maybe I put this on backward. That's strange. Yeah, so it goes on the other way. So you have to load the spool in from the back. You slide it on like that. And the spool holder's neat because it has this rubber foot, so all the weight is just on the desk. Right here. So it's kind of isolated, if you want to think about it that way. This whole spool is just isolated. A little bit flimsy, but it's isolated. And then I can't tell if it feeds from the top or the bottom. That I can't tell. Because if you feed it from the top, it kind of has an awkward angle. If you feed it from the bottom, it has a chance of rubbing. I don't know. What do you guys say? Top or bottom? Probably the bottom. Like so. It's a little weird that it feeds in the back, but it is what it is. So to load filament, you press this little lever, and as you're pressing it, you feed the filament in. It's kind of a nice solution. Like that. It's not super clear, but you should be able to see it. That's kind of a nice solution, honestly. Although it's not time to load filament. We still have to do the wiring for this. Yeah, let's connect some wires. I installed this a little bit early, but that's okay. So do note that this takes up a pretty wide amount of space for what it is. Having a spool on the top is beneficial for saving, width. But if you have this on a shelf, like what's behind me, that would be ideal to have the filament on the side. So depending on your situation, you can do either. Now there are 2 screws on the top. I'm wondering if there is a alternative filament holder that you can put on the top here. There might possibly be something, but yeah, there's 2 heat sets for screws. This just clips on, so there's no way of just putting it on the top that I can see. But that's an interesting note. That if you want to mount something on the top, there are already holders there. So for wiring, let's see. How the heck do you wire this printer? So we have this big bunch of cables here. It's a funny stepper motor positioning angle. For the extruder, it's kind of cool. So it actually, they have a cutout here. It makes sense. And honestly, that's perfect. A lot of printers have it wrong where the stepper motor's in the front. So all that weight is applying a large torque on the tool head, but this is way more balanced, kind of like Stealth Burner. It's almost exactly like that, so I think that's a good idea. We have this giant ribbon cable. Let me find some pictures of this. How does that attach? Do they have any pictures with the cable? So it somehow attaches to this. Is that what this is for? So we have this type of like plastic thingy on here. Let's just get this installed first. So we have end stop right here. This is the end stop, the 3-pin. We have the motor connector that goes down here. And, oh no, that was wrong. E. What is E? E end stop? There's an E and there's an X. E. What is E? I'm so confused. So PE, protective earth. That will attach to this right here. Which is, again, kind of cool. Just a single JST. Or sorry, not JST. Disconnector. Extruder? Well, the extruder's over here. And it's only 2-pin. That's why I'm confused. And it's only the length for this. So we have X. So I'm definitely going to connect X to X. But what the heck is E? Filament runout sensor? Oh, okay. So a hypothetical future runout sensor then? That would make sense. So there is no runout sensor currently built in, but I see an extra screw here that might attach to in the future. Thank you. That clears that out. So you'll just have a dangling cable. Right now, this is very sloppy. That is not ideal. Let's just get this attached and see how it wants us to cable management. I don't know if there is any cable management. There's this. I'm very confused what this is. Where does that attach to? Is it attached like here? That would conflict with the Boasting tube. It doesn't look like it attaches onto this. That locks in place. Like so. Okay, that clips in like this. And does that go on here? Okay, that does. So this is the strain relief for this, allegedly. Yeah, it clips onto those side pieces. So this will provide a bit of strain relief. If I can get it on. There we go, it's a tight fit. Now, what the heck? How does this work? That's what I'm confused on right now. Like, does this whole thing just dangle? There's no way. I guess we're going to have to read the manual now. Read the manual. Cut the cable ties, install these. Filament holder. Alright. X limit switch, X stepper, protective earth. Doesn't even show the extra slot. Strain relief. Then what? Secure cables and filament tube at the indicated position. Okay, so they want us to run this whole mess of cables underneath here. What's easier to undo at this point? Let's undo this right here. Sometimes it's good to not read the manual, but then reference it when you get stuck. because it's pretty basic, but yeah, it's not. This is kind of a weird step. So I think I saw what they were referencing. Where are those? They're like these little plastic clips. They're in here. Won't rub on the bed like the new CR10 SE. I haven't really seen that one. So we are cable managing against the Boasting tube, which is perfectly fine. So it wants us to attach on 3 points. So we're going to run this under here and start up here and just kind of slide the ribbon cable into here and then press the clip into the Boasting tube. We'll do one more in the middle, like so. It's going to make these all go the same way. You can put them however you want. So that slips on like that and like so. So that'll kind of hold it nice and neat, and the Boasting tube actually gives it its arc, so a little bit of support. Pretty good idea. Yeah. So the most you'll ever go is like right here. Yeah, right here. Not bad. This though, this is very jank. I don't like this at all. So the fact that secure the cables at the indicated position using zip ties. So it wants us to use a zip tie. Where? Here? It wants us to zip tie it right here. Using one of the included zip ties. So you're telling me I need to zip tie it like this? Yeah, that's exactly what it tells me to. Like that. Still, now we just have this mess of dangling cables. We have all of these right here just kind of hanging here. I don't like that. What I do like more is when there's a like breakout board on the Y motor. How does the the Ender goes straight. How does it work? It doesn't do this. Yeah, I don't like this. I'm expecting there to be some type of mods to contain this mess. Like, that's just ugly. And it kind of interferes with the spool too. Yeah, not great. All your pumpkins finished, John? I'll have to take a look at that after. Alright, well, it is what it is. So all the axes move smoothly. I'm not going to do any tensioning on the axes. I'm going to use it as is. The belts, we'll just check the rough belt tension. Seems fine to me. The y-axis seems fine to me. And we are ready, I think. We are ready. So they include a spare nozzle. It looks like a pretty standard volcano. Overhand the filament so less risk of tangling. I think the angle is too sharp if you go over and in like this versus up like that. So I'm gonna have it go under like that. Just kind of it feels a little more natural to go like that. I don't think it's ideal, but I'm just gonna preload it into here until I feel some resistance and then stop. So it is time to power it on. Let's grab the power cable. Twisted Tea looks awesome. Yes. Yeah, I still get the signage board that KB3D made for Earth. Lovely, lovely display. I'm not keeping it there forever, but at least for a few more days to get some use out of it. So the power inlet is on the side. So we're going to plug this into the wall and then plug it on the side. We have already confirmed, actually confirmed like Uncle Jesse, that this is set to 115 volts and then power it on. Get Anycubic logo here. The screen's small, but it's not too bad. I don't love how close the PEI gets though. So take a look at this. Look how close that gets. I don't like it. So if you have a misalignment, like at all, it's just not gonna work. Okay, I guess the distance between the PEI to the rear extrusion is, yeah, you gotta have this like dead on. And more importantly, if you're using an Ender 3 PEI and you're trying to center it, you might get real close. That's pretty close. It still works. I would probably center it so the corner is on this side and it overhangs on this side over here. Oh, that won't work because I'll hit that. Wow, you really got to center it. Oh boy. Yeah, so using an actual Ender 3 bed, you just got to manually make sure it's centered. So it looks like there's a end stop here, but that's not really an end stop. It's a pressy thingy. Okay. That's weird. So we have two things back here. Let's put the PEI back on. So again, I like how it has a nice metal double-sided texture PEI. And it's on a rigid bed. Ooh, our bed is super loose. Oh, wow. Oh, no. We have to tighten our bed already. And this is why I praise the Ender 3 V3 SE. Even though it had V-wheels on the X and Z, having linear rods in the Y meant that you'll never have to tension it. So we have to figure out what is loose on here. That's all we check. So the toolhead's good. Toolhead's great, but the bed is just loose. I thought we could get away with not doing that. I guess I have to find my wrenches. Where the heck did those go? Didn't gone too far. Here they are. So it is a rigid mounted bed, but the incorrect style where it's just standoffs on the 4 points that would be manually leveled. So as the bed expands, it's going to warp with this design. Just naturally. There's no room for expansion. If you're going to rigid mount a bed, you have to constrain it at a lot more points, specifically in the middle. So, yeah, incorrect. So the reason why I don't like trying to tension beds, because we have to like get the wrench down here and kind of guess, you know, the tension level on it. Kind of a weird setup. The holes in the magnetic sheet. I'll take a look at that in a second, but I'm going the wrong way. So I'm kind of tightening this and feeling the opposing V-wheel to see how tight it is. And you don't want it too tight, but you don't want it loose at all. You will be replacing V-wheels in your bed a lot more often because they need to be tighter to maintain the correct stiffness. So let's see. That's a lot better. I'm going to keep it like that for now. So the bed is actually more or less rigid. Have you ever had V-wheels that didn't need to be adjusted? Well, the X seems fine out of the box. I'm not touching the Z. Maybe the Z could have a little more tension. No, I'm going to leave it as is. But the bed just needs some more. Now, I don't know what's going on with these extra slots because it makes no sense. I think it's just for a different style of bed, so they have like one magnet for two beds. Otherwise, it doesn't make any sense to have an extra cutout here. Alright, I will be using a... I will be wiping this with isopropyl alcohol, as you probably should before you do any type of prints. Let's do that now before we heat up the bed. Just spraying on some iso, and then wiping it down. Just to get any type of factory oils just kind of spread out. This is not an equivalent for washing it, but it does kind of help just eliminate any immediate issues. I think we're good. You think we're good? Let's actually read the instructions. So once again, I don't like the wiring. It doesn't look ideal. Does it want us to put another zip tie in there? Hopefully. Somewhere? No, not at all. Okay. Adjust V-wheels. Check if print bed is shaking. Yeah, it was shaking all right. Adjust tension. I think it's fine. Screen overview. So it's not a touchscreen, but it does have a nice little knob that we can select through. So we have our, let's see, on the side here we have home and settings. So I'm guessing, yeah, home just brings it up to here. If you click that, it's home page. Weird. So that button does nothing. That's a checkbox. I don't know what the checkbox does. Let's insert the SD card to see if there's anything on there. I think for time's sake, I might actually use a pre-slice something and get a print going. What happens if I click it now? Okay, yeah, so if you click this button up here, when an SD card is in, you get some different settings. So included, we have a 40-minute benchy. That's a 0.2. I don't know if it's speed benchy rules, but it's a 0.2 benchy. 30-minute benchy, that's 0.25. A dinosaur, that is 1 hour. A shark beer bottle opener, which has an unknown amount of time. And a spider, which is 19 minutes. Spider, that could be fun. But let's not do that yet. If I click the second button, that preheats. Okay, so we're now preheating to 60 C on the bed and then 190 on the nozzle. Sure. See how long it takes to hit temperature on the nozzle. Settings. What do we have? We have home page, motor off, move axis, filament, auto level, module calibration, more settings, fan off, language, about, restore defaults. Okay. Speed, we can increase the speed of our print, and Z offset is right here. So to adjust your Z offset, I guess while you print, you just click this, and then you go up to here. You can do up or down. So it's not as easy as a Prusa, but there is a way to adjust the Z offset natively on the panel. So I don't know if this has a routine where the start G code will level it before it prints. A lot of these printers, you have to manually level the bed one time. So we can try that. So first we're going to preheat the bed. Ooh, that's already pretty hot. Yeah, we're already at 60 C on the bed and we're at 190 for the nozzle. So not as fast as a standard like CHC style, but pretty quick for PLA. So let's go into the settings and then auto level, and then auto level yes, and we'll see what it does. So we're going to home for the first time. It is activating the part cooling for whatever reason. Preheating. Preheating to 220C. And then 60C on the bed. So it does preheat before it levels. That's correct. You have to preheat your bed before you level because at different temperatures it'll have different amounts of leveling. different amounts of warping. There we go. That's a better way of saying that. While that's doing its thing, I'm gonna check a couple prints out that I had. Had some turtles by Build Overbought. Oh, those are cute. The little keychain turtles. Built Overbought. Bilbo and Thangs. I like it. This is in some Capricorn temperature changing filament. So if I leave it on the print bed, it should change temperature or color. That's funny. Those are cute. And then this is the color that we're going to be trying to print with. This is a Cookie CAD Pale Blue Elixir. So it has like a bit of a sheen sparkle to it. Has some like glitters. Looks really nice in person. So it's preheating. It's trying to stabilize at a temperature. I'll typically set up macros to not necessarily stabilize when doing something like this because it takes forever. So I think it's trying to stabilize the bed right now. It's at 61, it's trying to hit 60. Yeah, it's almost at 60. It's getting there. Okay, and we're at 60. Oh, homing failed Z. Oh. Then you connect the Z stepper cable. And then you power on the printer for the first time. You go into auto level and you click auto level for the first time. There we go. We're going to wait for it to preheat again. I don't know what this is for yet. I am intrigued. It's not a scraper. I don't know what it is. What could this possibly be? Let me see if it comes in the like instructions. I have no idea. It's not in the list. What is that for? Anyone know? Any ideas? What the heck this thing is? It says Anycubic. Is it a keychain? I don't know. We are at leveling. Alright, so it is probing. Oh, dear lord. What did it do? I don't like that. It was heavily pressing down on the bed and actually sunk right into the bed. What was that trying to do? I don't like that. So for Z offset, there's actually a like switch in the back here. The switch here, and then there's a little like plastic bit, which I think is for nozzle wipe. But like, yeah, it like goes in. So this is the actual Z offset switch. So why did that not work? Let's try turning it on again and just doing a Z home and see if that works. Yes, I did you know, take this apart a little bit. So it's possible that I unplugged something. Not gonna doubt myself. So let's go to settings, move axis, home all, and I'll be on that power switch just in case. I just want to make sure that it actually is able to home. If it goes up, no, it crashes into the bed. That's not supposed to happen. It's almost like the inductive sensor is unplugged or something. Hopefully it's not defective. All right, where do we start troubleshooting? First of all, we want to make sure that this ribbon cable is in correctly. That little piece fit near the switch. I don't think so. Not really, no. No, I have not looked up like a review of this printer beforehand. I'm wondering if I should take this cover off to make sure the connections are good. Connector E that you left unplugged. No, because that doesn't go anywhere. Right? That doesn't actually connect to anything. There's nothing else for it to connect to. It doesn't even say in the manual. But that should be like a sanity check, right? Like if the probe is not connected, then it should throw an error, right? Right? Let's unplug this and see if there's any obvious things that are wrong. I'm not going to fault the printer just yet because it could have been me, but this is not looking great. I just want to push some plastic, you know? Though it does... the cover does clip on, so you unscrew those two covers, and now it's clipped. So you can do this. But let's see where this is. It does look connected. Yeah, it looks connected just fine. Okay. This thing is pressed in as much as it can possibly go. So that cable is fine. Okay. I doubt that anything underneath was undone. I did read the instructions. I did. I can go back through and see if I missed anything, but we did install frame, PI sheet, Hotend, attach that, plug in screen connector, plug in spool holder, put in the Boasting tube. We have the X-axis limit switch and cable, protective earth, and Z stepper motor. Those are all installed. Wire management, pulleys, and then YOLO. So, I don't know what else to check besides taking off that bottom cover again, which is a huge pain. I can try reseating this ribbon cable and seeing if that works. If I can even take it off. This strain relief cover is really on there. I think it's snapped in place. But we did get fan spin, and the nozzle did heat up, so that didn't throw an error. Let's just double check this is pressed in well. It's pressed in as much as it can go. Put that back on. I'll try it one more time. See if anything's changed. I will be very cautious. Let's put the screw back on for the for this cover as well. My next video is gonna be I'm setting it back. I'll try it one more time. If it still fails, then we are going to take apart the bottom and see if anything got disconnected there. That's a possibility. Is this not lining up now? No, I gotta like push it into place. There we go. Okay. All right, one more time. Let's go to settings, move axis, foam all. Nope. Ace is crashing straight into the build plate. I'm 98% certain that's not supposed to happen. I'm almost tempted to look up another review of this thing and see if that's actually how it homes, but it should not press down on the thing that is not supposed to move down. The inductive sensor height adjustable, the trigger at all. That's a good question. It is height adjustable, but it should be set from the factory to be correct. But I can try loosening it, or if that's an option. Again, that shouldn't be anything that I have to do out of the box. Kind of weird. Okay, let's take off this cover one more time then. Well, I gotta say, my experience with the Ender 3 V3 SE was way more positive than this. And that one does have automatic Z offset too. Uses a real probe instead of inductive probe. Let's just take this front cover off. We don't actually need that yet. And then check out this right here. So it's pretty firmly held in place. Looks like we can loosen it, but is that really what we want to do? A little clip on the yellow thing under the Hotend. This? Or are you talking about this weird thing? I don't think that does anything. I still know what this is. I don't know if it's relevant. But do I really want to loosen this and move it down? I don't think I have any other real options at this point, right? So let's loosen this up and see if I can move it down at all. I don't know how this is attached. Looks like I can screw it. So I'm screwing it down a little. So it's just above the nozzle. And then retighten it and try again. No, it seems to be failing on the Z-home. The nozzle is just crashing into the bed. And I want to make sure that that's not correct. Oh, your message, you put the plastic thing around the nozzle and sit the probe. Oh. Oh, is that actually? Is that the instructions? Is that actually in the instructions? To adjust the... Start printing. It's not in the setup, at least. Troubleshooting. No. Okay, troubleshooting guide. If there is a leveling anomaly, follow the following steps. After powering off, check the wiring of the level calibration module. It's just not doing a entire Z-home, so I don't think it's a leveling issue, I'm guessing. But it does have an alignment process for when it does the actual end stop. So you're saying you put the plastic thing around the nozzle and set the probe on the other side. Around the nozzle and set the probe on the other side. It's like this? Is that what you're saying? Like that? That's probably exactly where it was. Just for kicks though, I'm gonna leave it as is, because it's hypothetically lower than it needs to be. So let's go and do a move axis, just homing all. Just want to home all. I shouldn't do anything with that rear switch. Ooh. Ooh. Did I unplug the x-axis? Oh. Oh, shoot. That's my bad. The cover does have to be on. It actually homes against this cover, which that's not great. That's my fault. Let's get this back on, at least temporarily. I don't have to screw it in. It should be able to just kind of sit in place and kind of snap on. Okay, let's try it again. Does the nozzle reach the little switch? Yeah, it looks like it will. But that's not the Z end stop though, right? Look at Anycubic's video, a build of this. You're doing everything right. That's good. As far as I know, this is only used for leveling. This is not used as the end stop because it has a standard inductive probe for the end stop. Is that correct? I guess there's one very easy way to test that. We can go into move axis, home all, and then when it does a home Z, we can just press this button. In the video, it didn't use those buttons. Okay. Let's see. Let's see. Yeah, that does nothing. So let's see if it'll home at all. No. Oh, yeah, okay. It did. Okay, it did home. So the inductive probe was too high to start off with. So that was actually an issue. I had to manually lower the inductive probe. That's weird. That should not be like that. If I was a new user, this would be going straight back in the box and back to Anycubic. Okay, well that's a thing. I don't know if I have to adjust the probe at all, but it's higher than the nozzle, so I'll just leave it as is for now. And we'll try the auto offset. Let me just preheat it first. Whoops. I can't see what I'm doing here. There we go. So yes, it did home Z. But only after completely removing the cover, which it does not come disassembled. And I do not recommend removing the cover unless you actually have to. Then I had to manually slide that down. I kind of just guessed, but apparently there's this thing. Apparently this is how you set the height. I didn't use it. Alright. At least the bed has steering relief on the cable. It's good. I want to get a print off. That'd be great. So let's go into settings and then auto level. I'm not going to do the module calibration. I'm going to assume that it's set correctly out of the box. Well, it's heating up. I have to fix my AMS real quick. Fun fact, if you have a Bamboo Labs AMS and your spools are too light, you can take like something like a 2-inch ball bearing and just slide it into your spool, and that'll keep it from moving around, kind of like that. That's a great way to weigh down the spools. Because when they get too light, it'll sometimes cause issues. So in my case, when it's under half weight, I just throw one of those balls in typically. All right, so I think it homed. I wasn't actually watching. But now I don't feel confident because it crashed into the bed. Okay, oh, it is spewing filament onto the extrusion. And it's just going to leave it there. Okay. And then it wipes on that little plastic bit. That's pretty good. Okay, and then the Hotend is cooling down with the set point of 0. That's weird. It like almost goes into that hole. Yeah, it does need a poop bucket for sure if it's gonna do that. I don't know if it does it for every print, but it's weird. This is the auto leveling process. Okay, when it goes under 150, it then presses against that little switch. It's not perfectly centered, but it's reasonably close. Press it twice. And then it's probing The front. Okay, now it's doing a bed mesh. So what I don't get is, how is that doing an auto Z offset? Like, what's the, how is it doing that? Because I don't remember it actually probing the end stop. Unless it's assuming that it has that specific bed thickness, and that it's using just the inductive probe to get a measurement of the height of the bed. Like maybe it knows the difference between the bed surface and that. Maybe. Because typically for the auto Z offset for something like a clicky PCB, it actually physically probes against the end stop with the probe. And then you have to give it that dimension. You have to give it the offset. So I'm wondering how it works when it's not physically probing that switch. I don't think it was probing the nozzle or the inductive probe against it. It's also very annoying because every time it lifts up the nozzle, it turns on the part cooling fan. It's going like whoosh, whoosh, whoosh. That seems like it's a firmware issue. I don't know why it would have to do that. It's like leave it on or turn it off. Pick one. It's also taking forever to make a mesh. So I'm not going to set the slicer today. I don't really have time for that. But what I will do is run one of the test prints that comes preloaded. Hopefully they've tested those. Okay, now we're good. So hypothetically, it is auto offset, auto calibrated, and then it poops right onto the side here, which is very beautiful because it's that fancy filament. So without waiting too long, let's do the. Do I have to save that to my save config? Maybe. It doesn't have like a store config. So I'm guessing it's saved to config. Let's go to the settings and print the spider. I don't know what the spider is, but it's a 19-minute PLA print. It's preheating to 215. That's a good sign. A lot of pre-sliced profiles only print at 220C. Or sorry, 200C. That's just weird. A lot of filaments now are designed to print hotter. Yeah, the print temp for this is 200 to 230, so makes sense. And the reason why I chose the Cookie Cat is because it has a lot of sparkles in it. I am testing, it's not an abrasive filament as far as I'm aware, but I'm just testing just the general printability just for a small nozzle. Like it'll clearly work or it won't work. For comparison, this was printed off of a 0.5 CHT clone, just a brass nozzle. So we're preheating the bed, and then we're actually heating up the hot end. Wow, it far surpassed 215. It went right up to like 225. I don't know if it needs a PID tuning or whatever, but it's a little bit off. Okay, so he heats up the nozzle all the way. That's kind of weird. Yeah, it heats up the nozzle, and then it turns it back off. No, it keeps the nozzle heated. Is it actually printing? What is it doing? What is it doing? What was that? Is it trying to print? Excuse me. Were you trying to print there? Because you're not. There's no filament coming out. Now there's filament coming out. Okay, I'm gonna stop that. It is printing a spider. That is a spider. So I guess after the calibration process, it doesn't purge enough filament. It's weird. This is pre-sliced G-code. I can't really criticize it too much, but I can because it comes with the printer. It's using, let's see. So let's compare it against the volcano nozzle. This is a Micro Swiss volcano, and this is a nozzle that it comes with. Yep, it is a bone stock volcano length nozzle. The tip is a little different. This one kind of has a weird, like, a weird end compared to its standard one, but it's the same length. Okay, kind of weird purge. Very weird purge. But that's just the pre-sliced code, so I'm not gonna complain too much. But it is printing 215 for the first layer. My Z offset was automatically set. It's now at minus 0.82. It was at something like 2 point something. So I did lower the inductive probe manually, and it did compensate for that. So whatever it's doing in the firmware, it's working. The offset looks, I can't really tell. Might be a little on the high side. Ooh. So, oh, okay. Never mind. It drops down to 195. So it does a 215 first layer, then drops down to 195. It is a volcano Hotend, so you don't have to have temperature as hot, but still 195 really. Just gonna send it. It's a small spider. It's tis the season. Tis the season. So, well, that's printing. Let me just go over some of the specs of this printer. It has a new integrated extruder, which we sort of saw. Levy Q2 has an auto leveling system with a little switch. We saw it do that. Features input advancement, or sorry, linear advancement and input shaping. So this is running a version of, I'm guessing Marlin, that has input shaping enabled. That is one of the features. I'll probably connect this to my computer, and then actually I can do that right now, can I? USB-C. Let's connect this and pull the config and see if it has an input shaper profile active. Let's see if this cable works. See, so what software is that? Pronterface? We're on Pronterface. It is printing. It's printing reasonably fast. Like, that looks pretty decent for a little bed slinger, right? It's a good test of the Z offset too. because there's very small details. Alright, let's connect to the printer. Printer is now online. Okay, then we're going to run M503. Alright, let's see. So I don't know if I can share my screen, but I'll just read off the details. Filaments, settings, disabled. Step per unit. So the extruder is set to 455 E-steps. Acceleration. Max acceleration, X 2500. Make this bigger. Can I make this bigger? No, I can't. 2500 on the X and Y, 800 on the Z, and then 2500 on the extruder. So that is faster than the standard like Ender 3, but still not crazy fast. I think the Ender 3 limits were 4K. We have power loss recovery. Looks like it's on. The bed does have a PID tune and the Hotend as well. So those are pre-PID tuned. The Z offset is set. And it does have input shaping enabled. So it does have it for X and Y actually. Cool, so they have set this up correctly, I'm guessing. So it has an X 55.7 and then D 0.15, whatever that means, and then the Y is 52.7, D 0.15. And then it does have linear advance enabled too, which the Ender does not. It has a linear advance value of K 0.6. So that seems pretty standard for something like this. Sensor is on, apparently, for the filament runout. That doesn't really make sense because there is, as far as I can see, no filament sensor. So yeah, there we go. Simple as connecting this to printer face and just pulling some values. Let's unplug that. Power loss recovery is on. I would probably turn that off. We could test it, I guess. I don't know generally why you'd ever... Well, I know why you'd want to have it on, but I don't know if it has any downsides. Well, we're printing out a cute little spider. It's a fun little test print. Is this spider like their logo or something? Because I saw a spider on the build plate of their image. So this printer is available for pre-order right now. I pre-ordered this a little while ago, and it arrived right before I left for Earth, so I wasn't able to do an unboxing of it. But it is printing pretty much perfect at 195. I'd probably bump up the temps a little bit, but it seems like it's printing. Quality so far looks pretty good. And we are using this CookieCAD Elixir filament, so not the easiest to print compared to something like a standard PLA. How much more time do we have to do? Only 7 minutes in. 8 minutes in, it's a 19-minute print. I'm just gonna let it print. Yeah, so this has hypothetically everything you need. So let's talk about the plus sides to this printer. Input shaping built in is quite nice. That means you'll be able to run it faster with better quality. It is not the same input shaping as Clipper, but it is good enough for, you know, like bed slinger speeds of unparalleled. It has auto Z offset, which I don't know how perfect it is, but it looks like it's doing a pretty decent job. The pre-sliced G-code that came with the files just was not great. So I'll have to check out the slicer start code and see if I can. Hopefully it's improved. Let's just put it that way. So auto Z offset, great for beginners. You just hit the button and it works. Now, it did come with an incorrect setting, or something was just not working with the probe. I had to manually lower it, as not in the instructions. That will cause an issue if the nozzle just starts crashing into the bed. But positives, so we have input shaping and linear advance, great features for a printer like this to get better quality. The part cooling fan looks actually really good. Like, there's not many better designs for a single fan that I can see. So it has the dual ducts. It looks like it's well thought out and well designed for part cooling. Great for PLA. The noise, it's loud. It's not quiet. I'm wearing my other headphones today. It's not a bad noise, it's just audible. Pretty audible. But seemingly pretty decent part cooling. You can always turn down the fan too if you feel like it's too much cooling. Comes with a very nice PEI sheet. This is on par with a lot of the other sheets that I get. I don't like when it has like labeling like this on here. I like just a plain black sheet with maybe a logo on it, but it's fine. It's better than the filament one, which has like all this stuff on there. Like, that's a bit much. But yeah, very, very similar to that sheet. And this was a premium add-on, so they definitely spared a little bit of expense for that. It's honestly not that much more over a typical sheet, but again, a nice bonus to have, and it's gonna make first layers very enjoyable. And that's kind of why I wanted to check this printer out, is because it had a lot of features that beginners need, right? They need a way to have auto Z offset. None of that paper leveling. This has no bed leveling screws, so you just send it. You do the auto leveling, it sets the value, does the bed mesh, and it's good. You just send it. And actually, you can argue that because it only has single Z, the gantry will stay correctly tilted. The issue with dual Z sometimes is if one motor becomes desynced, then you'll get a tilted gantry. But because we're only driving it from one side, it's not going to do that. Complicated. I'd rather have the Ender 3 V3 SC style where it has the single motor, but then it's belt tied. Even dual motors, but just belt tied Z. That is very ideal for something like this. You'll never have to adjust the Z tilt ever. Twisted T, yes. So this printer did come with me to ERF. It was a lot of fun. I did get some prints off. In fact, the print that's on it, I haven't taken it off the build sheet yet. It's just on there. It's one of these IK3D dynos. So that was a lot of fun. The side spool, it's a little flimsy. It's very flimsy. It does not feel premium, but the fact that it's off to the side is pretty nice. I know it's not gonna weigh down the top of the printer, but yeah, it just feels very flimsy, extremely flimsy for what it is. I don't know why, but it's not great. I'd like to see a better improved system, which fortunately they're just using extrusion, so someone's gonna come up with a better design for this. There's already stuff that exists. I don't know why they've included such a a cheap spool holder. Just look at it wiggle when it prints. Should not be the case. Tensioning, that's pretty standard now on every printer. The screen is small, but it's good enough. It doesn't stick out any further than the tensioning knob. It's a little close to the bed. I don't love that. But it doesn't add any extra Z volume. And it's kind of at a nice height too. Any other benefits? Assembly was reasonably simple. I don't like the way that I had to install the Z-axis, but it's fine. It is absolutely fine. The top is linked with just a plastic piece. There's no extrusion going between it. And it's working. It's printing. It looks pretty much perfect. Yeah, looks like a perfect print. So, assuming that the nozzle, I should probably report that back to them and say, hey, my bed was crashing, and that they probably have to lower the probe during assembly or something like that. I don't know, but the probe height was not set up correctly. That's a major downside. If that's the standard installation, and if every single one of these things fails during homing, then that's an issue. I almost feel like they didn't test this at all before sending it. A lot of printers, like an SB06, I believe is tested. You can tell because there's filament in the nozzle. So it seems like this was not tested to save money. They just kind of put all the parts in the box and then send it over. So the quality control definitely is minimal with this printer to make that low price point. They've also just used V-wheels for every axis. Given, I mean, we're looking at nearly perfect print quality. Fresh V-wheels can make very, very, very good prints. No problem with that. You just got to be careful over time as they wear out or if they get loose at all. And it's not going to be easy to upgrade to linear rails, so I'll just leave it as is and print like this and kind of share my experiences with the V-wheels as we go. This wiring is just a mess right here. I don't like that. I'm guessing someone's going to make a mod to contain that a bit better, as well as the spool holder. Uses USB-C to connect. Yeah, it's getting with the times. That's good. I was able to connect direct to Pronterface and get some values, and I'm sure I could use that to run some other commands too. When you run this with Octoprint, using USB-C is going to be nice. Volcano Hotend is a very, very nice addition on a cheaper printer because you're probably not going to change your nozzle much. Just be honest. You're going to get a nozzle and you're probably not going to change it. So it doesn't matter that it's volcano length. And there are additions in terms of quality to a volcano. Because there is more heat capacity, it's able to extrude at a more consistent temperature, which means your overall quality is going to be better. And it has a sock on it. It's already better than a Prusa, right? Yeah, I am enjoying this much better now that I fixed that. Fix the probe. But those are my first impressions for this printer. Does anyone have any questions that are still watching? If not, leave a comment down below. If you have any questions about this printer, chances are I might have experienced it by now. Had the impression that volcano nozzles are more prone to stringing. So, it depends. Hypothetically, yes, because you have a longer melt zone and you have to retract more. But because this is direct drive, and the volcano aspect of it means that you can decrease the temperatures, even in probably up to like 10°C to get the same results. That would help with stringing, because there is absolutely no stringing whatsoever on this print with this filament. It's not a great test for stringing though. Is there a magneto-electric upgrade available? Yes, there is. You can just buy a whole entire MagLab system. Pretty complete. So 19 minutes and 9 seconds. Not bad. Let's see. We should be able to just flex this right off because it's a PEI sheet. Let's see. I think this is just leftover junk. Let's clear that. So the first layer quality looks pretty good. I'm trying to see this in person. Like hairs. So let's zoom right into here and see. So this is our first layer. Looks pretty much perfect from what I can see. Right off the bat. Our wall quality, it's a little bit cheating to look at the body because it's a curved surface, and curved surfaces are always going to look better. But if we look at the legs have pretty uniform Z. Not the best filament again for testing this because of the sparkles, but yeah, this is like a 9.8 out of 10 print. Like I would not ask for a better print off of this. Seriously, I don't have any complaints. Only praises. Z offset looks like it's close enough. It could probably use some tweaking, but yeah, it's pretty much good to go. Yeah, the cookie eye filament is really nice. Let's see, is there filament management in here? Let's preheat the nozzle and go to filament. Retract. Okay, let's see if we can do an not auto, but manual filament unload and load. Yeah, while we're at it, we might as well set up a profile and Orca Slicer. Let's see if there is this printer already in there. See what's the closest thing. Maybe Prusa Slicer has a profile for this. What slicer do they tell you to use? Do they? Do they tell you to use a slicer? I guess you don't use a slicer with this. Let's go to prepare. Let's see what we have for Anycubic and Orca Slicer. Might not be any. Alright, Anycubic. We have the Kobra Max, Kobra 2, but that's not the Neo. I can try the Kobra 2. What's the difference between this and a Kobra 2? Is there anything? Oh, yes there is. But let's see. 3D printers, Kobra 2. Just a bare bones basic Kobra 2. Looks identical, looks like it has a bigger screen. Looks like it is still Marlin. Does it have input shaping? It looks like it has the same tool head. Dual Z though. Smart offset. Oh, that's the printer with the SG rails. Yeah, that's right. Yeah, so the Kobra 2 for damn it, only extra $60. Extra $60, you get SG rails, which are like V wheels that ride on metal metal rods instead. With dual Z, that is 100% worth it every time. So just like and it has a filament sensor. Yeah, so just like the Ender 3 SE, Ender 3 V3 SE, it is worthwhile looking into the 1-up machine. So in this case, this is the Kobra 2 Neo. I would definitely look into the Kobra 2 if you have not purchased your printer yet, because it has dual Z, it has much better rail system, and a filament sensor that mounts right up here. So just that alone is definitely worth $60, or $80 when it's not on sale. I think it's pretty much the same otherwise. Looks like it. Yeah, pretty much the same otherwise. Has a different colored PEI sheet though. It's weird this one's black and that they've included a standard looking PEI for the Neo. So for $200, is this worth it? So far, with my one print off of it, I can say probably. It's probably worth it. But I'll definitely be doing more testing on here to confirm that that is the case. For sure. So let's see if I can load this printer into Orca Slicer. Did I click the button? It's an Anycubic, right? Anycubic Kobra 2. Confirm. Anycubic. Why is it not showing up here? Anycubic. Weird. Let me try closing out of my Orca Slicer instances, because that should work. That should work fine. There's no physical differences between the two. They both have the same system. So I'd be surprised if the start code for the Kobra 2 didn't work with this. Alright, try this again. Confirm. It's not showing up. Let's try closing out Orca Slicer altogether. If not, I'll use Prusa Slicer. And we'll get a print going overnight. I think we've retracted the filament. Let's see. So, see what it did. Not an ideal situation for the filament, but it is what it is. Yeah, so it made a little bit of a wisp when it retracted. And the filament tension looks like it's pretty good. It's a little bit on there, but nothing too bad. So let's try some Polymaker filament as an overnight print. We're going to stick with something basic. So let's do a regular PLA. Yeah, let's do orange. It's almost Halloween. So let's try some high TD orange. So I'm going to slap that on here and load it like this. So this printer caters very much fine to cardboard spools. It doesn't care. Let's do extrude. Okay. It is extruding. There we go. Thank you everyone who stopped by today watching this live. Once again, if you're watching this in the future, make sure to like and subscribe. And if you have any questions, leave a comment. If you have answers, also leave a comment. I'm curious to know if anyone else had that same issue with the probe. Let me know if you ran into that issue. I'm curious. And if you bought this as a pre-order or if you bought it off the shelf. Because I wonder if they'll change the design up a bit. But overall, it's a functioning printer. I can't complain too much. Files. Oh, purchase slicer. So interesting. On the SD card, we have Anycubic slicer, which we're not going to use, but it has purchase slicer 2.6 loaded on there. It has suggested parameter profiles. So it has a init file for, I'm guessing, purchase slicer. So let's actually just upload or we'll launch purchase slicer because it looks like. Oh, okay. I have the Anycubic Kobra 2 loaded into Orca slicer. That's fine. 0.8mm first layer. Who the heck made this profile? 0.8? That's a little aggressive. At most, I want a. Let's just do a 0.55 first layer width. And a first layer height of 0.24 instead of 0.28. It defaults to Arachne. I'm gonna turn that off. I haven't liked Arachne. And let's leave everything else the same. Speed. So default speed in Orca Slicer for the Kobra 2 is 4550 first layer. Outer wall 150. Inner wall 150. That's pretty fast. Sparse infill only 70. Solid infill 150. Top surface 120. Interesting. And then the generic PLA is set to 0.98 for flow. So we could try that, or we can launch Prusa Slicer and import a config file from the SD card. And see what that does. So for the print settings, 0.2, 0.28, suspiciously similar. Speed is 150 for everything, including sparse infill. So it looks like that's pretty much the same profile. They just kind of messed up the profile Orca Slicer. Do I plan on converting my Rook 2020 to Mark 1? Absolutely. Yep, I have it sitting right over there. I was just waiting for it to be released. So I'll be rebuilding my Rook 2020 to Mark 1. Okay, the filament profile for this has a flow of 1 in Proof Slice. I'm just going to use Orca Slicer for now. And I'm going to change the sparse infill to 150 from 70. And leave everything else the same. Yeah, I know it's released. I've been busy doing RepRap Fest, and now I'm doing an unboxing for this printer. I think it extruded fine. Let's try one more. So let's get a print set up on here. What do I want to print overnight? Release the complete config. That's good. We have a few models that we can use. Let me do one of these dinosaurs, the chubby T-Rex model. That will be a good test of overhangs and wall quality. And it's not too big of a print, so it's just one of these. So this is the chubby T-Rex Dino pencil holder / pot, no supports on printables. So let's load that into Orca Slicer. I've not calibrated my flow. I haven't done anything like that. I'm just using the default profile that it gives me. So it's yelling at me for something. I don't know what. Machine G code. Relative extruder addressing requires resetting the extruder position at each layer to prevent loss of floating point accuracy. Add G92E0 to layer underscore G code. Is that layer change G code? For layer change G code? To layer underscore G code. I'm guessing that's after layer change G code. So it's telling me to do a G92 E0 after the layer change, which will reset the extruder. And it's working. Okay. Perfect. So it's the 3 hour and 34 minute print with the semi-stock profile. Let's export this to the SD card and load it in. Now I don't mind SD card printing. But I prefer to not, if I can help it. So it looks like we've definitely extruded enough. Let's go into the settings and print this Rex. There we go. What's our filament profile as well? I didn't even check that. So it's printing at 220 for our first layer and all layers at a maximum volumetric flow of 12. You can probably go more than that. Like I said, I haven't tuned this profile at all. So I'm going to work on making a custom tuned profile for this printer on Orca Slicer / Prusa Slicer. But we'll see what this does. I'm guessing that it uses the saved bed mesh. And it's just gonna... I don't know why it homes a Z all the way back there. That's kind of weird. But it homes a Z and then immediately starts this like purge. But it doesn't actually purge during that. Like the purge is here. It's a weird setup. It's strange. So I'm guessing I need a slight Z offset change. It feels like, yeah. It definitely needs more offset versus what it has. For this specific print. I don't know what's changed. If anything has changed, but on the spider model, it looked like the offset was sufficient. But on this new slice from the slicer, that's just not enough. Jerk is set pretty high though. I can tell the acceleration is pretty high even for the first layer. It is set to default, so whatever default is in the firmware. I just don't like the outer layer because it's a little bit not pressed down. But I was expecting to manually have to set the Z offset a little bit, tweak it. Anyway, I guess. Looks like it's fine now. Maybe a little bit more. A little slower than I'm used to, but it's all good. Yeah, that looks better. So I had to adjust the Z offset a little bit, but it was pretty much good to go. Definitely better than just doing like a paper leveling test, for sure. So what I think I'm going to do is see if I can save this. I'm just going to stop the print. And my Z offset is at minus 1.02. Alright, when I stop the print, it homes the printer. Yeah, clearly wasn't good. So let's go back and reprint that same exact file. Now that our Z offset is set fairly well. Remove the little bits of filament. Definitely gonna want to adjust the starting G code. I don't like it. Usually Orca Slicer has better starting code, but in this case it's not great. So the little, yeah, it doesn't even clear the nozzle. It still has a blob on it. It looks better. For some reason though, it still doesn't look like it's laying down perimeters that well. There's definitely a gap in the perimeters. So let's try lowering it a little bit more. Now we're at minus 1.12. And I'll just leave that as is and let it print overnight. See how well it does. So this has been a interesting unboxing and first impression of the Anycubic Kobra 2 Neo. My first immediate thought is that it's probably worth looking into the regular Kobra 2, the non-Neo, because it will solve some of the future issues such as dual Z and V wheels on the X and Y axis. But for 200 bucks, I think this machine is definitely worthwhile. The tool head is definitely a solid looking unit. The wiring leaves something to be desired. The spool holder as well, but I like how the spool holder is off to the side. The screen is very simple and it works. Nothing crazy. USB-C, uses micro USB cards. The build quality is typical for this class of 3D printer, nothing exceptional. Yeah, it works. It works. So thank you all for tuning in to see this unboxing. I will be doing a review of this as I spend more time with it. I'm also going to directly compare it against the Ender 3 V3 SE. And maybe in the future I will have some of the upgraded models on this channel. So if there are any printers that you want me to check out, please leave a comment down below. I'd love to check out some of the new Clipper machines, such as the newer offerings from Creality, just to see what manufacturers are doing with Clipper. But for a little Marlin machine, this is running pretty good, and it's going to be great to have a backup printer. So that being said, thank you for watching, Make sure to like and subscribe. If you want to catch more content like this, I do live stream on Twitch at twitch.tv/zombiehedgehog. So I spend more time doing random things and building printers. Just a kind of a mix between what I do here, but we have fun on Twitch, so make sure to check that out as well. That's it for today. Have a great night, good morning, good evening, and goodbye.